In this video, we're going to be discussing how to solve this question on Algebra 1 in the subject of graphing functions. So, graphing functions is actually pretty similar to graphing quadratic equations or parabolas or graphs of circles. All we have to do here when graphing a function is figure out some points that satisfy the function that it can output, then plot them on a coordinate graph, like we see here, plot some points and then connect them with a line. That's pretty much all that's been done to create this graph here. So in this video, we're going to be answering some questions on this particular graph using information we can find within the graph. So the question states, function k is defined by the graph shown, assuming grid lines are spaced 1 unit apart. The first part asks, what is k of 1? So they basically want to know what's going to be the output when the integer 1 is input. Actually, when the integer 1 is input to the function k. That's basically all this is asking. Nothing complex here. So, to do this, all we have to do is take a look at our graph here. So, we know that the input's going to be 1. This is the x value, because for any function, the definition of a function is k of x equals some output. So 1 is the x in this case. Now, an interesting thing you can do here is since 1 is the x input, all you have to do is go to the 1 on the x-axis here to get the value for y, and y is always going to be the output, so that will tell you the answer. So if 1 is the input, all we have to do is look on the graph, we find the 1 here, that's on the x-axis. And then we find out which point on the y-axis on the graph of the function this corresponds to. We can see up here, this point, y equals 2, corresponds to x equals 1 on the graph of function k. So that's all for our question. K of 1 is simply 2. For part B, we have a similar thing, k of 5 here. Again, we just look at the value for the x-axis. 5 on the x-axis is right here, and then the value for y that corresponds to that x equals 5 is 4, right up here. And this is defined within function k because this is a filled in or closed circle. You can see the blue filling there. That means the function includes this point, so the answer to that question is 4. It's defined within function k. Now we have a little bit more of an interesting one involving the composition of the function k. So first we have k of negative 3. We're working from the inside out here. K of negative 3, we look for the value of negative 3 on the x-axis. Then we find the value corresponding to that on the y-axis. But then we notice that this is not a valid point within the function k definition because this is an open circle, meaning that this point is not included within the definition of function k. So that means this value is undefined because this inner part is undefined, and of course k of undefined is just undefined. So that's the answer to that question. We don't have an answer for that. It's undefined because it's not within the bounds of the function. And finally, we have if k of x equals 3, what is x? So now we're going in the reverse direction. We're told that k of x equals 3, which means our value for y is 3 up here. Then we simply find the corresponding value for x that satisfies this. So we're told that k of x equals 3. Then all we have to do then is figure out how to solve this question by looking at the x-axis. To solve the question, all we have to do is basically run the technique in reverse, like we did in the previous parts. So the y is 3, that corresponds to an x of 0. So that's the answer to this question. So 0. Okay, that's for the first part of this. And finally, the second question, is explain how you know that the function k has an inverse. So the inverse function of any graph function is going to appear like a mirrored or flipped graph. And we described briefly on inverse functions in a previous video, but in a graphing background, it's a little bit different. So an easy way to tell if a function has an inverse without going through algebra and finding definitions and manipulating variables and all this stuff, without going through all of that, what you can do is simply employ something called the horizontal line test. So it's exactly what it sounds like. The horizontal line test simply involves drawing a horizontal line through the graph of your function at any point. Horizontal line here doesn't have to be straight, just any line. And if the horizontal line passes through or intersects two or more points on the graph of the function, then the function does not have an inverse. And this is so because this tells us that if the horizontal line intersected two or more points, then it means the inverse function would have had two or more outputs. And as we know, a function can never have two or more outputs because then it wouldn't be a function at all. So that tells us we can see there's only one point of intersection here, this point, when we drew the horizontal line. And you can see there's no other point on this function that fails a horizontal line test. Here, it all satisfies the test, nothing wrong. So that tells us there's only going to be one output for the inverse function, which confirms that function k has an inverse. You just say here, it passes the horizontal line test. And we have to be specific here because there's an entirely different test that's used for a different application within functions, and that's called the vertical line test. That's used for testing an entirely different thing that we'll cover in a future video. So all we need to know there is that there's only one point of intersection on the horizontal line, and so the function passes the horizontal line test. And we've successfully answered all parts of this question. In this problem, we basically solved this entire problem on graphing functions in Algebra 1 by going through and using the information provided to find values on the x-axis and their corresponding values on the y-axis on the graph of the function. And then we use the horizontal line test to tell if the function k actually had an inverse, which it did, because it passed the horizontal line test. And that's it for this functions and graphing functions problem in Algebra 1.